And this is it. This is the final episode in our number system series, all about shifting binary numbers to the left and to the right and what that does to those numbers. So a shift can be performed on a binary number to the left or to the right, and normally on a byte of data. Remember what a byte is? That's 8 bits, 8 digits. When you do a shift, you shift it a certain number of places to the left or a certain number of places to the right. When you shift them, if you're moving to the left, then you'll end up with some blank spaces or some blank digits on the right hand side. You need to fill those with zeros. And if you shift to the right, the same will happen with the left hand side. You need to fill those with zeros. If any digits are shifted out of that byte, you discard them. That's why sometimes you can get inaccurate results. So let's look at a left shift example. This one is a left shift of 2 places. Have a look here, the rightmost bit. This 1 is shifted across 2 places. So it goes from where it was here, once, twice, it's now here. You see there's some blanks now. Then this one was the one that followed it, which would have been here, is shifted 2 places. But I find it's easier once you've shifted the rightmost bit. Just fill in the rest of the number here. So there was a 1 after that, then a 0, then a 0, then a 1, then a 1. And these 2 zeros, well, they're gone. Then what you do is you fill in those blanks with the zeros, and this is your new number. Have a look at that. What would that number be? Remember your binary columns? The rightmost one is to the power of zeros, so that's 2 to the power of zeros, that's your 1s. Then it's your 2s. Then that's 2 to the power of 1, then 2 to the power of 2, which is 4, 2 to the power of 3, which is 8, or just double each time. 1, 2, 4, 8, 16, 32, 64, 128. So what number did we have originally? We had a 1 and a 2, so that was 3. No 4s, no 8s, a 16, that was 19, and a 32. So 32 and 16 is 48. Plus the 2, that's 50, plus the 1, so that's 51. And what number do we end up with? Well, no 1s, no 2s, a 4 and an 8, that's 12, no 16s, no 32s, 164 and 128. So 128 and 64 is 192, plus the 12, remember, the 4 and the 8. That should give you 204. So as you can see, that's doubled the number twice, or multiplied it by 4. So each shift is a double of the number. 2 shifts is a double of a double, which is 4. Let's look at a right shift example. Starting from the leftmost one, shift it across 2 places. This is a 2-place shift, by the way. Goes from here, once, twice, and then again, I just start filling in the number after that. So it's another 0 after that. Then it was a 1. Then it was a 1. Then it was a 0. Then it was a 0. And then these 2 1s, they can't go anywhere. So actually, they're discarded. They're gone. These blanks, you fill in with zeros, and that's now your number. When you shift a number to the right, you halve it or you divide by 2. So if you do it by 2 places, you half it, and you half it again, or you halve it and halve it again. And that's the equivalent of dividing it by 4. So what has it done to that number? Well, what do we have here? We had a 1 and a 2, so that was 3, and then a 16 and a 32. So the number here is 51, and then what you've done is you've shifted it twice, so you should have that 51 and then halve it again. Well, 51 halved is 25.5, and if you halve that again, that's 12.75. But what do we actually end up with? No 1s, no 2s, a 4 and an 8. So you have the 12, but you've lost the 0.75. Now A level, you'd actually be able to work out what this 1 and 1 where it went and work out the point part of it, the floating point part of it. But for GCSE, it's gone, it's just 12. So that's why it's slightly inaccurate. But for a GCSE question, it'll normally ask you about what the effect is on a particular number, and that's where it expects you to say it's halved or it's multiplied, depending if it's shifted left to right. Let's show you another example. Standard left shift of 1. Here's your number, and we're going to left shift it once. So what we're going to do with this 0 here, I'm going to left shift it so it should be able to go into here. And that means then that 1 should be able to go into here, this 0 to here, this 1 to here, this 1 down to here, this 0 to here, and this 0 to here. And that 0 to there. Remember, we're working in 8 bits though. So how many have I used here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Too many. Let's chop one of these off. That's gone. We've got a blank here. What do we need to do with that? Put a 0 in there. And that's what we've done. 0, and that's your new number. Quick check. No 1s, 1, 2, no 4s, an 8, and a 16. So that's 24. That's 26. And what number do we end up with? No 1s, no 2s, a 4, a 16, so that's 20, and a 32, so that's 52. So we turn it to 26 into 52. We doubled it. That makes sense. What about a right shift? Here's another number. We're going to right shift it, so we can go this way this time. Let's start from the left edge. Let's move this 0 down to here, this 0 down to here, this 0 down to here, this 1 to here, this 1 to here, this 0 to here, this 1 to here, and this 0 to here. How many bits have you used? 1, 2, 3, 4, 5, 6, 7, 8, 9. Too many. So let's chop it off. That's gone, discarded. Got a blank here. It's got to fill that with a 0. And here's your new number. Let's look at the number here. What have we got here? So we've got a 2, an 8, and a 16. So we've got here 26. And then what do we end up with down here? A 1, no 2s, a 4, and an 8. Nothing else. So we end up with 13. So we turned the 26 into a 13, which is what we expect. When we right shift, we halve it. So about discarding these bits, you're losing them. So if you don't have enough binary digits to record where all these digits are going, you're going to have some inaccuracies. So if you do a 3 place to the left, and you shift this number, 101101111, you're going to go and lose these leading 3 digits, 101. And then you're going to end up with this, which is not, if you think about what a left place shift 3, that's multiplying it by 8. Those two numbers aren't, that isn't 8 times it. Same with a right shift. You're going to shift that way, you're going to lose these 3 numbers. So you're going to end up with, those 3 numbers are actually gone, and they should be like representing decimals. So a question might be about what will happen if you don't have enough bits to represent your shifts. You need to say about inaccuracies. Your turn. Go to Edmodo. Try the number systems binary shifting quiz. Last quiz you'll do on Edmodo other than the end of topic big one. Go and have a go at that. Take your time on it. You've got way more time you need. Don't rush it. Have a go. So that takes us to the end of this whole series. You've done everything on number systems that you need for GCSE. But I need to know if you've remembered all of this. So have a quick look. How do you do binary shifting? You should know that now at the end of this episode. You should be able to add 2 binary numbers together or 3 binary numbers together. You should be able to shift left or right. Tell us what happens to those numbers. Tell us about inaccuracies. And hopefully you got up to the point where you can do the challenge now. Give the answer in binary if you have the starting number in base 10 of 37. You add it to 37 in base 16. And then that answer you get, shift it 1 place. What do you get? Now, some of the keywords there, overflow and underflow. If the bits go off to the right, that's underflow. And if the bits go off to the left, it's overflow. Now it's time. It's time for you to do the Edmodo end of topic quiz. You will not see these answers. You will not get a redo. This will go to your main influence of your grade when I work out your current working grade. Good luck. And if you need to get hold of me, you know how to. Cheers.